My name is Aarno. I'm from Switzerland, so I came all the way overseas to talk to you about how we use, how we do DevOps for LLMs. So for the past 11 years, I've been working on providing 24/7 support for software developers to run their software as 24/7 running online services, especially for financial, insurance, health, and government clients. And we do that now in a team of 40 people. We have an office in Zurich, Switzerland, an office in Vancouver, Canada. Both of them are probably about the same distance from New York City. Right? So what is this DevOps I'm going to talk about, right? So it's the collaboration between the software development, focus on the code processing and storing the data, and the operation, which is more focusing on the metadata or the management plane, deploying the code automatically, ensuring observability of the production environment. And so that's what we've been doing for 11 years now. And of course, most software systems or most applications nowadays consist of more than one software part or software piece that needs to be coordinated. So how do we do that? Well, for the past 10 years, we've been building these kind of GitOps pipelines, right? So automating the processes to get the software from Git to Kubernetes, and then have all the tooling basically already ready to give the observability, give the what's happening actually in production back to the software developers so that they can make informed decisions about how to continue developing their software, right? So this kind of continuous improvement workflow. So how does AI fit into this DevOps picture? So in my talk, I will talk about the LLMs, so large language models, which is a specific subset of generative AI and deep learning. But of course, many of these are applicable to other parts, of course, as well. So what's the difference between DevOps for traditional old school software, I already have gray hair, and DevOps for LLMs? Especially when LLMs are paired together with traditional code, like for RAG or agents or other stuff. Well, first, as you might know, generative AI models are probabilistic. They basically roll a dice based on the context to determine the next word of the answer. That means if you need the same answer each and every time, don't use LLMs, right? But it also means that there's actually quite a few differences to like the traditional deterministic code that we're used to, right? Small changes in the data, no matter it's in the prompt or the user input, can make the model behave completely different. For example, we tried to localize a chatbot for an event, and we changed the prompt for "you're a helpful chat assistant" to "you're an Easter-themed helpful chat assistant," and it completely threw it off. It wasn't able to answer any questions anymore. It was completely broken, right? So small changes in prompt, small changes in instructions can make a huge difference, right? So does new types or versions of models generate new different output for the same input, and of course show that testing and validation is even more important in this kind of non-deterministic software than it is for even junior software developer written code. That if your software not only consists of code, but also of different data sets that are used for training and validation, that's of course not something we can quickly implement in GitHub Actions or GitLab CI. So that requires different tooling, and I'll get back to KubeFlow in just a second. More items need to be versioned means that also more items need to be stored. So instead of GitHub or GitLab pipeline pushing a few dozen megabytes of container image into registry, you now have a few dozen gigabytes of LLM models that need to back up to be able to debug cryptic error messages later. And coming from a mature world of well-maintained Docker files and images that you can basically pretty much pull directly and put an ingress on top, the LLM world is much more fluid and complex. And I'll come back to some of the tools like VLLM and LLMD also in just a second. Non-deterministic also means we need to log much more context, like the full requests and responses, so that we can go back and audit and go back to debug what actually went wrong. Because you don't only need to log the input, and then you can figure out what happened afterwards. You also need to log the output because anything can happen in between, right? With new possibilities also come new responsibilities, like user input intent detection to filter out rogue manipulative queries, Or risk management, not only based on the data being processed, but also on the use case. So for example, the EU AI Act requires you, also if you use non-confidential data, but if you use it in a medical or therapeutic context, it's already red flag. So that's not only the data being processed is important, but also the how you use it and how the customer interacts with it. So compared to unit or the integration tests, where you have like a test case and you compare like the string or the number coming out, evaluating if an answer of an LLM is semantically close enough and does not introduce factual errors or hallucinations, that's actually quite a hard problem, right? You require manual analysis or another LLM to evaluate if the first LLM did the right output. So now you have a 2 LLM problem, right? So that's not something that we have, at least we haven't solved it right now. Different models also restrict how we can use them. Closed models, and for example, OpenAI ChatGPT, GPT-4 is of course one of the many, a lot of our customers also use that, but that's only accessible as a hosted service. That means that you usually can choose like the major version of the model, but you're not in control of which specific minor update or when that specific minor update is rolled out. And you can't download a specific model as a backup or for local testing or on your laptop if you're offline. So open weights models and open source models, on the other hand, you can download. You can run it on your laptop, you run it on your own production environment, and then you can roll out a new version of that after validation and testing according to your own schedule. And that's much harder with the closed source models. For example, using Ollama, I always colloquially call it the Docker for LLMs. So Ollama provides both native bindings and an OpenAI API-compatible endpoint, which has established itself as an industry standard. And just like Docker, Ollama is kind of the quick and easy way to do that, but it does not provide like load balancing or high availability, which is, of course, one of the reasons we all started using Kubernetes in the first place, and we have a KCD like we do today. So on Kubernetes, we use KubeFlow, and actually I think there's at least one KubeFlow maintainer also here. Thank you for your work. So that's a set of Kubernetes operators that handle the different phases of model development and model production, running, inference in an open source Kubernetes operator way. So the KubeFlow pipelines, which is the blue phase, that help with the CI/CD, and they help especially if you want to train custom models. Could be LLMs, but mostly the other models, right? And for LLMs, most of our customers at least don't customize the models, they don't retrain the models, they just run the models themselves. And of course, that's the red part, that's the inference part, which is actually taking care of the operations basically of the model. And the KubeFlow component that does that is called Kserve, which is basically the infrastructure agnostic Kubernetes operator that can run on any cloud or infrastructure, and then handles the actual running of the models and basically the application server for the model, which there are, of course, plenty of. And here's, of course, no KCD talk without some code. So here's an example. We have I don't have a pointer to show. So on the top, you see there's the model is specified, Llama 3. And then below that, you see that there's the Hugging Face token, which is basically the access keys if you're allowed to download it. Then you see the image, which is basically the application server. It uses VLLM, which is, again, just a regular container pod that then loads the image. Then you have like the resources, and you see that it takes a GPU. And then below you see, for example, the logging. They're configured to log all the requests and answers to this HTTP internal logging endpoint. And then you can see how Kserve then handles the scaling. And then the Kserve controller, Kubernetes operator, deploys that using Kubernetes deployments, runs the containers, which then run, again, the LLM models, and then you have basically a Kubernetes service that you can then run against. And optionally, you could also use Knative, basically as a serverless deployment of the same thing. And Kserve then provides you with the observability around that. So it shows you here, for example, the request timing, or here the infrastructure that's running, and that's our like Grafana dashboards that are already provided by the K-Serve KubeFlow project. So that's, of course, makes it much easier. And maybe as a short outlook, about 12 hours before the deadline for these slides, a new project was introduced called LLMD, which is basically a more specific inference Kubernetes operator for LLMs. And that, in addition to using the same VLLM runtime, basically adds not only the caching, but also like the request routing and the model selection and model scaling scheduler. So that's our like specifically for LLMs, and that's something K-Serve hasn't done before that. That's all I had. As a day job, I do have an open source project that does, it's an app store that runs on Kubernetes that deploys not only these tools, but also like databases, cache queues, reverse proxies. Input is very welcome, and pull requests, of course, as well. And with that, thank you for your attention, and thank you for organizing KCD.